So, welcome back to our course on smart energy distribution. It's time to look again at what we have done last time. So, last time we have looked at topics in connection to smart homes and energy management. What kind of things have we looked at? That has all been long ago. Talked to you about the potential of electric vehicles. That's where we started last time. We talked about how we can use their flexibility in a reasonable way. I showed you something about the smart home environment that we have here on KIT campus. Talked about the energy related issues. I showed you this view on the on the building, on the architecture, on the scenarios that we look at. We looked at how to classify degrees of freedom for household appliances, and then we continued with all kinds of things. I showed you some ideas of how one could actually modify the schedule of a day, a very simplified view, just to give you an idea of what kind of things could be moved around there. And certainly this will not be done manually, but if you have a possibility to modify the runtimes of devices, then this should be done in the most automated way, but certainly with interaction also with the users. And for interaction, we have the energy management panel. I showed you or gave you a view on the energy management panel. We looked at what the current situation was in the house in our energy smart home lab. Looked at the interfaces for actually getting information on what the current status is, and also on this menu to actually specify the preferences for letting the device or the appliance run. And like this can be done for tumble dryer or for a washing machine or dishwasher. It's important to, for those devices to be able to interact in a simple way with the user, such that they can specify the preferences. And then we continued, looked also briefly at the menu for the vehicle, and I showed you something about organic computing, because this is the motivation or the kind of system architecture that we use for our energy management systems, and so we have looked at that. We looked at organic computing. I showed you a little bit about what's behind organic computing. We looked at the different devices that we have there, the observer, the controller, and that it is a three-leveled architecture. And then we came back to the system. We looked at the way this is actually used there. I showed you that we can generalize it in some way to get some kind of generic architecture. And here I showed you how we could actually use that in some hierarchical way, such that you always look at the current system under observation and control, which could be just an abstraction of some real entities. And I also showed you this view on the system where we actually address the complete architecture. And I would like to make a remark on this, because here the different instances here of this architecture are operating on, or maybe operating on very different time scales. So if we just look at that from the software point of view, this is some architecture which is having some optimization facilities and so on. And so we can do something on a larger coarse-grained time scale. Whereas if you look at grid control, for example, you will have many decisions which have to be done on a real-time time scale, and so very fine-grained. And so there you have to be aware that if we have something like this, we have to be operating on similar time scales, and this is not always the case. So it's just indicating a principal possibility to extend this architecture into very general settings, but it does not mean that this is the only architecture that is necessary to operate the grid, because there we have to look at the different time requirements. We looked briefly at self-consumption, self-supply, that we would like to optimize that, and I showed you how we do that with the optimization approach that was designed in the organic smart home architecture. We looked at how it is done there, how these elements are represented as subproblems and problem parts. We're having this bit vector which abstracts from all the decision alternatives, the evaluation function, which then can be used to actually get an aggregated load profile. So here it looks a little bit strange if you remember how that looked like in the animated version. So if I could go briefly into the animated version, just to remember, to remind you, here we have the different load or the individual load profiles, and then they are just merged into some aggregated load profile. And so that was that part. Then we looked at, well, the result is then just the best performing individual, and we continued looking at the FZI House of Living Labs. That we also looked at. I showed you all the ingredients of that house, many different components, combining electricity, heat, cold, and gas, so different energy carriers, different forms of energy that can all be managed in this house, and we do that in many different simple scenario or different scenarios. We have to look at the way these systems actually can communicate, how we monitor these systems, the electricity part, the thermal infrastructure, and yeah, this was the addressing the communication infrastructure that we have to look at. And we also there have this energy management panel, which is an extension of what we have in the Energy Smart Home Lab. And it's obvious that depending on the target group or target persons, the users, you will have different types of energy management panel requirements or interface requirements which have to be considered when you design such a thing. Okay, then we continued looking a bit again at the different topics we are looking at in our research there, and I think now we are close to the final slides. This was showing the logical structure that we are actually addressing in those more regional energy management systems, where we have to respond to bottlenecks that are detected by or predicted by the network control system, by the distribution system operator, for example, and then he would send some requests for changes for demand response activities, which would be sent to the market if there is time enough to do that. Unless, like if there's not sufficient time, then it will be sent directly as an activity, as a command to actually respond immediately. And so this is, in some way, it is the predecessor of what we call the Ampel model or the traffic light model for energy management, which is looked at in more detail in the grid control project, which we are just now working on here at Karlsruhe. And this is now the first news slide for today, remarks on other commercial smart home solutions. Before I continue here, I would like to make a remark that we have we are just advertising our exchange program with Australia. So if you're interested in exchange, you can, like there is an exchange program with Newcastle, University of Newcastle, Australia. Two places you can apply by June 17. That means end of next week. I don't know whether you are aware of that. Somehow nobody applied so far. we are advertising that every year, starting in May, and the deadline always is mid-June. So far, this year, nobody applied so far. And it is an opportunity to spend 1 year at Newcastle at a quite good university, and you can actually get, or you have a chance to get an additional grant here from KIT to support that to some extent. So it's quite an attractive exchange program. So if you're interested in that, or know people who might be interested in that, just apply for it. Certainly most of you are in master programs, so it is maybe a little bit late, but you can also write your master thesis there. So this is something which might be of interest to some of you. Okay, yes?
Where can we find more information?
Pardon?
Where can we find more information?
AIFB website. There you find information on it. Okay, now I would like to tell you a little bit more about other examples of smart home management systems. So there are many systems around. You may know, or you may have seen that there are quite a few companies who are offering this now. You see that like on TV spots, that you can control your home more easily nowadays with your smartphone and things like that. So just give you a few examples, very few examples, in addition to what you have seen with the organic smart home energy management system. So this here is RWE. You know, RWE always has gives the impression of being very, very innovative and providing you with the most recent and innovative technology. What do they offer? They offer a smart home technology where you can actually monitor all the devices or many devices that you have in your house. And you can see, for example, that a certain light is on, and you can measure the temperature. And here is some timer. So you can set certain times also when a certain device or light should be switched on or off. But this is more or less a monitoring software, where you just see what's currently going on in the house. With certain devices, you can install smart plugs in your house, and then you find out what's going on those smart plugs. You can give them names, and so you see the current situation in your house. It's not providing anything which is going beyond manual monitoring and control, or a little bit automation, because you can set a time and then an action will be triggered at that time. A light will be, or a smart plug will be switched on or off. That's what you can set. But it's not beyond that, so it is very different approach from what we are doing. We are, like in the organic smart home, we are optimizing the schedule of the energy schedule of a house depending on prices and things like that. This is not at all addressed here. Okay. But it is certainly something which is nice. Then there is something which is called ambient. There are ambient technologies, so something which is just around you. And here's an example like ambient devices. They say here, with more power, people use less energy. Nice slogans. And so their idea is similar to what we have seen in the ENBW, the Stromampel, this traffic light concept, that a device is displaying the current energy situation. So here, if it's green, this is a nice situation. It's a low price, or it's an incentive. Should be an incentive to actually use your washing machine now. Whereas here you have a red. This is colored in red. So this shows that somehow this is a high price. As you see here, there's high energy consumption. So that's a time where you should not use that much energy. This is just to use colors, as we have seen in the ENBW device, which we used in Merigio, that something where you get information on the energy situation, on the market situation, and in this way get some incentive to respond to that by shifting your energy usage to green times away from red times. So very similar to what we have seen there. And you can go to the website, look at, they have quite a few devices, and you see they have more than that. They also show here some prices and several things they show on this display here. And then there is the Nest technology. This was very, like people got very aware of that technology because Google bought Nest. And what is Nest about? Nest is a device to control the temperature, to control devices which actually heat your house or cool down your house. And so it is also a device which gets aware of the presence of people. That means there is just some movement detector in there. And so this is more or less all about that thing. So here it just says away, so nobody there. Here it says 72, that's the temperature in Fahrenheit. So this is a self-learning device. I will tell you a little bit more about that. It's a self-learning device. So initially it doesn't know about the preferences you have in your house. And then if you install that in a room, it will notice when you are there. You can set a preferred temperature, and then it will notice when you are there, and if you are not there, temperature goes down. If you are there, temperature goes up. And so you have to train that device to control the heating in a reasonable way. Now, certainly next day, if you are not there, the system knows, oh, usually you will be there or will come home, let's say, at 5 p.m., and so the system has seen that a few times and it learns at 5 p.m. you are there, so it will make sure that if you come at 5 p.m., the room will be warm. The next day, if you come 2 hours later, the room will be warm at 5 p.m. And so it will notice, oh, nobody there, so maybe it can respond to that, but it is just a device which learns about the presence of people in rooms of a house and then tries to adjust to the preferences of the people with respect to the temperature or the climate in the house. And there are nice experience reports of people who have bought such a device. They say if you want to make sure that this device learns how it should actually keep the temperature in your room, you have to make sure that you always wave your hand such that it notices you are still there. And so if you want to make sure that the next day the room is heated in the right way, make sure you are there in time and teach the device the right way. Yeah, so this is not really intelligent. It's a nice idea. I just observe what's happening in a room, and I assume that the next day they will have the same profile, or at least if there are recurring profiles, they will learn that. But it does not really mean that you will save energy by that. Yeah, and if you get there and you have not taught the system that you have necessity to have a warm room or a cold room, then you have to wait for the system to actually respond to that. So there are several nice ideas, and the main idea that is important here is that this device, it learns something. Now, the learning algorithm is not inside this small device. The learning algorithm is somewhere in the Nest company. And it means that all the data that is monitored here, all the data is sent to Nest. So this is from there, it is sent to the Nest company, and there the processing is done. And it means that all the data about the presence of people in a house is sent to Nest. And this is interesting data. And that's why Google was interested in it, because Google is always interested in getting information on the behavior, on the activities of people. And so if using this Nest device, they get more information about what people are doing, that's something which is of value to them, so they bought Nest. And but if you look at the websites of Nest, you find all kinds, or of related websites, you find all kinds of experience reports of people who are not really happy with it, but are more or less annoyed. Okay, and there are also there have been some statements on how much actually you can save, how much energy you can save if you say, I would like to, like I'm at home at certain times, let's say in the morning a little bit of time, and then later on, late afternoon, and it means that at those times I would like to have a high temperature, and in between it's sufficient to have a lower temperature. But now this depends on how fast, or the efficient, or the way you can save energy depends on how fast your house cools down, how fast it warms up, and so it means also like how long before do you have to start heating up the house such that at this time you actually have that temperature. And so the calculations of how efficient it actually is to have a device where you set the temperature for a specific time during the day to a specific level, these calculations are a little bit complex, and they show that the savings of that are not very large. And in particular, if you have devices where you can set the time where it should, where your radiator should warm or should heat the room, then if you don't have a stable time schedule or a stable profile, presence profile in your house, then you would have to reprogram all your controllers on the radiators every day, and this does not make sense. So quite often these intelligent controls of radiators do not really save that much energy. Okay, but this is just a side remark. Nevertheless, it is an approach to actually control the environment and make sure that you get the conditions that you request actually, and the system learns your preferences, and then if all works well, you don't have to set the temperature anymore by yourself. This is just learning your preferences, and it might work fine. So I don't want to make it, or to let it appear very bad at all, but there are just some problems with that. And then there are other systems like Plugwise. Plugwise is a company which is mainly providing or producing intelligent plugs. And intelligent plugs, you know what that means. So here are intelligent plugs, so you can plug them into your sockets, and then, or your power outlets, and then you can monitor and control what's happening there. And there are all kinds of products that they sell, like different configurations of servers, and like here you see you have some system on your smartphone, you have a certain interface to some other place, that's the basic setup, or here's the basic setup. This is the interface. Here you have smartphone and interface. Here you have also a few plugs, and then you can certainly buy more and more plugs. They are communicating using Zigbee, and they are building actually some kind of ad hoc network. So if you have here your station, you have where you, like this is your interface or your Plugwise box, and then you have the individual intelligent plugs that you put somewhere. Then they connect in some way, build in some kind of ad hoc network, and just forward the information through that network to that central node there. Now, there is an app that is provided with this. On the app, you can see, you get information on the current status of your house, with respectively the current status of all the plugs you have in your house. And it means that you are accessing information which comes from your house, from your plugs. But in order to get that information, you access a server at Plugwise. That means all the information that is collected here in your house with these plugs is sent from this master box here to Plugwise. And then if you want to look at that, you can look at it on your smartphone or on your PC or laptop or whatever you like. And it means all the information of the plugs is sent to Plugwise. This is at a resolution of a few seconds, depends on the number of plugs you have there, because it takes some time to send all the information here. So the more devices you have, the longer time it takes to actually get successive measurements there. So you have at a quite fine resolution, you are measuring your energy consumption, and all the information is sent to Plugwise. And you have to pay for that. You have to pay to get those devices, and they get all the information about what's happening in your house. And so this is, again, showing it's a product where the producer of the product makes sure that wherever it is installed, they get all the information that is measured there. And they don't really tell it. You know, they certainly say that you can have all the software which gives you information on your consumption profiles and so on. And indirectly, certainly it's obvious they can only have the information at Plugwise if they have access to all the information. But they don't specify that explicitly. Nevertheless, it's a nice system. You can also, you can use those plugs and don't use that device. Use your own device, your own controller, and then get all the information from those plugs. It's also possible, but then you need your own monitoring software. So we do that in the field test that is still running. It's running now for 2 years in a number of households of our group. So I just want to make you aware of what it means to have intelligent devices in your house. And it's a very nice thing. But you have to be aware that certain things can, that others can actually use that information. Then there is a device which is similar to what I showed you from this ambient technology company. Here they have a white-colored device which also shows some information, providing it in different colors depending on, to give some incentives depending on the current situation. They also show here temperature or whatever, different types of information, like temperature, time, and so on. Okay, so Plugwise is a company which provides nice things. And then there's EnBW. EnBW is also providing nice software. This is the energy cockpit. This was designed actually similar at the same time as the Maregio project. And this is offered since then, together with their intelligent or their smart meters. And there you actually get information, or you can access their cockpit, certainly at EnBW. So you have your smart plug inside your house, and then all this information is sent to EnBW with 15-minute resolution. And this information then is stored there, and you get feedback on your consumption. You can look at the consumption at a day, in a week, in a month, and so on. Compare things, but only with respect to your own consumption. In other countries, like in Sweden, for example, Vattenfall is providing a service where you also get information on where do you stand with your energy profile or your energy consumption in your last month or something compared to other households having about the same characteristics. So that then shows you some relative performance indicators. This is not done by EnBW. So within the Meregio project, they had a slightly different interface. They also showed how much power you were using or how much energy you were using at red times, yellow times, and green times. So at low-priced, like green periods, medium-priced periods, and high-priced periods. And so there you have get some impression here for 1 week. You get an impression of like how green this actually is looking like. The more green it looks, the cheaper you have actually bought the energy. And then you can compare that. So this here, for example, is a typical profile actually from, this was from the year when was that? This was at, this is from 14, yes, 2014. This is actually a typical household, and what is so typical about this, you see that people, like here at about 1 in the morning, energy consumption went down. Must have been awake quite late, and then went to bed. And in the morning, there actually power consumption increased slightly. Maybe there was some water heating or something like that. This must have been breakfast here. This is typical breakfast. Some water has been warmed up or things like that. Then you have somebody must have been there around noon. And in the evening, again, something has been, or the stove has been used again, and some more activities, maybe light was on or things like that. And at that day, actually, they went to bed a little bit earlier. So you can see many things about what people have been doing on that day. And then you can, like on what you see on this slide also is that you can compare that now. Like it says Vergleich, you can compare it, you can select other days or other days, other weeks, other months. You can look at different aggregation scales here and compare your energy consumption with the consumption at previous days, the year before, or things like that. So this is quite some functionality, which is quite nice. And so you see, or you get some information services back from providing the data to EnBW. And like there's the website for that. Certainly, you will, since you don't have a login, you will not get detailed information, but this can be used. So here it's showing the annual energy consumption. Here actually this is like EnBW still, or like they have two different price levels that they actually display here, night and day tariff. And so night tariff is indicated in yellow, day tariff in gray. And so what you see here is the consumption over 1 year. Obviously, in the summer months, there's less energy consumption than in the winter months because there is more usage of light. There is more, like the heating has to run. We need just more energy in the winter times. Can be seen here in a very nice way. And then you can compare that again to other years that you can select. So this is quite a nice interface. And you can also, and this is it's an interesting point, you can also look at real-time data based on your smart meter interface. So this smart meter is sending, or is measuring the power consumption in real time, or with 1 Hertz resolution. For every second you get a new value. And so you can display that. So here you see the yellow line is the energy consumption. You see here there's a peak. Here you have a peak because maybe maybe the fridge has started, and then that's the initial power peak, or you have more, you need more power initially, then it goes down again, and you see also that it is a very unstable signal. There are always jumps around 5 or even 10 watt, so it's not just a straight line if a machine is running, but there are always some fluctuations in the energy consumption in a house. But you can see quite well what's going on here. So here, like we have 59 watt jump here, maybe that some light has been switched on or whatever. Yeah, so this is a very nice system or software which can be used inside the house. This data is not moved out of the house, but it's just accessible inside the house, sent by power line communication to the DSL device, and from there you can, like if you have a WaveLAN in your house, you can then use that on your laptop, the software, the Stromradar or energy radar or power radar, and have a close look at what's happening or what the current situation in your house is. It's a very convenient system. It's actually like the EnBW the screenshots are all from my house. Yeah, so I have that kind of device in my basement. Okay, so as I said, there are many different devices like that around, and just to emphasize that again, real-time data remains in the house, and we have the 15 minutes resolution data, which is sent then to EnBW. So, but only at a resolution of 15 minutes. There are other companies who offer smart meters. For example, a company called DiscoverG. Company DiscoverG, they offer you smart meters, and they actually measure the power consumption or the load profile at 1 Hertz resolution and send the data at that resolution to DiscoverG. So they get very fine-grained information, and they ask all their customers to sign a statement that they agree that they can use the data, and they actually tell them that they can do everything with the data because the customers have agreed that they can get the data. Yeah, so privacy is something which is not really a topic there for some companies, but this will be a topic in the future, I guess. Okay, I will come back to that when we look at smart meter technology in the next chapter. Then very short remarks on a technology that gets more and more important. Like if we talk about smart home management systems, we would like to improve our self-consumption of energy that we are generating locally. And so to improve that, we need storage. And there are some storage or some batteries available now on the market. And you can see here 2 products, although if you go to that website, you will notice that you don't see that anymore. So this is a very difficult market in the moment because the market is slowly developing. Because so far these devices are still quite expensive. And as long as it is more expensive to get power from your rooftop, not sell it to the grid, but use it yourself, but put it first into a battery and then take it out again, you have this extra investment also in the battery. And now it takes quite some time before that pays off because these batteries are still quite expensive. but we are all assuming that the prices will go down, and so currently there are more or less around 1,000 euros per kilowatt hour, and we assume that they will go down to something like 200 euros per kilowatt hours. If we are at that range, it will be a real bargain to actually store the energy locally and then consume it locally, because then you only per kilowatt hour that you use, like this is the investment cost per kilowatt hour capacity. If you look at the amount of money you have to pay for the energy when you move it through the battery, it's something like a few cents in the future. You are discussing something.
Yeah, we were wondering, the Tesla batteries, 3,600
Yes.
euros.
Yes.
And why is this so expensive?
It is 3,000 euros for how much? 7 kilowatt hours. But there is no environment for that. So there is not the management of the battery is not included. Yeah. If you look at so it's good that remarked that. I wanted to make that statement also. If you look at the cost of the batteries that are also in the Tesla cars, they are around 200 or even less than 200 euros per kilowatt hour capacity. But that's just the battery. It's not all the necessary electronics around that, the software managing that, and so on. And to have that installed, the price goes up significantly. Yeah? If you go to companies like RDS Tech, for example, it's a company which is offering batteries in the moment. They are even more expensive than 1,000 euro per kilowatt hours capacity. So it is still really expensive. But like at FZI, we are actually having batteries from RDS Tech, and we are having batteries from Tesla, or one battery from Tesla. And RDS Tech is giving a guarantee for a certain number of years. If you use the battery within a certain, like you have the state of charge, it can be between, let's say, 1 and 0. 1 is completely full, and they say, okay, as long as you use it only in this somewhere there, this boundary, only a very small interval of the state of charge. If you use it only in that region, then we guarantee a certain lifetime of that battery. Tesla says, okay, you can use the full capacity of the battery, and their guarantee is, I think, something like twice as long as the guarantee for the batteries that are available on the German market so far. Yeah, so somehow, maybe they are more risky. They just say, okay, it doesn't matter, and RDS Tech is very conservative, doesn't want to actually have to use that guarantee, but it is definitely a problem with respect to the business case for batteries. And now there's another case. If we all use batteries in our houses, then the distribution system operators and the energy providers will not be really happy, because all of a sudden they don't have to sell that much energy all the time, but only now and then, if there is not sufficient continuous supply of energy, then they will have to supply quite a bit of energy. And so they don't like that at all. And I was at a conference in Berlin about the status of energy research. That was 2 years ago. And there was some statement by a representative of a German organization of all the energy companies, and they were very grateful to the ministry, expressed their thanks that they would not install a new funding program or support program for like funding batteries and solar panels as combination packs, which is, from a technological point of view, does not make sense to just sell solar panels with respect to all the problems we have with the fluctuating feed-in of power. It makes much more sense to invest in controllable energy supply. And you only get controllable energy supply if you have an investment in solar panels plus battery. Then you can control at which time you actually want to use this power. So the problem is the energy industry does not like to have decentralized storage capacities in individual houses, because then they lose control about the demand for energy, and they cannot really calculate at what times they need or they have to provide energy and what times they don't have to provide energy. So they are really not very happy about that situation. And after this representative of the organization of the energy industry made that talk, there came the CEO of a large utility in northern Germany from the EWE, here EWE, and he said, well, he heard that statement, and it is clear that the industry in general is not really fond of that development, but he, as a CEO of this company, they are actually investing in those products because they see that the market for that will develop by itself, and so it's good to have products to sell on that market. Yeah, and so it's just something which is not really in the interest of the traditional industry, but it is something, as soon as there is a market, people will go for it. And there's also some additional incentive if you are independent in your energy supply from the energy utilities, then you have some additional incentive for that. You have a question? Yes.
And with help of battery would be so much easier.
Exactly.
One buffer storage.
Yes.
So I don't really understand why this would be a big problem for the industry, but it would flatten their extreme differences between demand and supply.
Well, so far we have all like the way we plan, or the energy system is preparing for being able to balance demand and supply, is that they make predictions on the demand for the next day. Now, there are certain standard household profiles, load profiles for typical households, and those profiles will not change that much unless people really get active in load shifting by modifying the times at which they use their devices. So, but in general, they have their standard profiles, and they can predict the power consumption for the next day. So there's some reliability on that. Now, if people have batteries, there still is this profile in the background, but what is visible to the company, to the grid, is a completely different profile, maybe very flat, or all of a sudden you get demand for power at a time where before there was no demand, at times where you had demand before. They are using their own batteries, and so they don't have the demand anymore. It's much harder for them actually to prepare and to plan for balancing demand and supply in the network. So it's making the job of the distribution system operator much more complex. Yeah, because they cannot plan that well as they could plan before. And maybe this will even out at some time, but as I said, if the market is there for having devices that can make you independent of the grid, and if that actually is cheaper than getting energy from the grid, you will do it. And so there's one thing which the industry is saying that's good, that is to have like a large battery pack for a complete quarter of a city, for a street of houses or things like that. And then you can make sure that you can even out the peaks there, and then this battery for a larger group of houses will be managed by the distribution system operator. And so then it will be used in a way that is beneficial not only for the houses but also for the grid. But if you're operating a battery just as an individual homeowner, you will use it to have the most benefit for yourself. And it's not in your own interest to have or to do something which is beneficial for the grid, unless you get additional incentives for that. Yeah, so this is just the problem setting that is there for using batteries. But as I said, the prices are going down, and so here you see it is 4.5 kilowatt active power and price around 7,000 to 10,000 euros. So it is quite expensive. And it will take some time before they actually will be around, but the market will be there, and in 4 to 5 years it will be definitely a business case to have your own energy consumption or energy generation from your rooftop plus battery. Then you have cheaper power supply than using it from the grid. Okay, you can look it up in the web. There are all kinds of power storage solutions meanwhile available, and this is a growing market. So if you have nice products there, there's one company which is very active there and which is actually which is offering benefits by using that kind of technology, the company BG, Better Energy, and we are closely cooperating with that company and actually testing their products before they come to the market, which will happen. Well, I think some products are already on the market. Okay, so let me just summarize what I told you about smart home technologies. We definitely will have here, we know that we have power generation from renewables, and for that we need new approaches to energy management. We have to make the demand more flexible. Electric vehicles are important components because they offer flexibility, which has to be utilized. It would be very, very bad or non-intelligent if you would just recharge a battery whenever it is connected to the grid. So there is additional demand and supply of power, but you have to use that in an intelligent way. So if you integrate them here, that's what is stated there. You can integrate electric vehicles in an intelligent way in the smart home environments, and then increase the degree of flexibility that you can actually offer. If we talk about flexibility of demand, we have to be able to discover the degrees of freedom inside a house. Actually, not just inside a house. We should also say home, building, factory, and there are potentials for flexibility to quite some larger extent than inside a smart home. And also in those larger scenarios, we have to look at that. In our organic smart home software, we have this energy management panel, which has the role of actually discovering flexibility, making information transparent, and then the organic smart home software exploits the load flexibility by optimizing the load schedule. Now, if we talk about Internet of Data, or Internet of Energy, I emphasized from the beginning that we have to be aware that all the problems we have in the Internet of Data will be transferred into the Internet of Energy, and so we have to be aware of safety and security problems. That will be the topic of the next chapter. We also have, like I mentioned, several projects on smart energy and storage at KIT. We had the Chrome project, ITSOS. We have Competence E. Competence E, actually, they are very active on new energy storage devices. They're actually providing a certificate now for home batteries. There are the Helmholtz programs. There's one program on storage and cross-link infrastructures, the largest energy program now of the Helmholtz Association. We have the project Grid Control, Living Lab Waldorf. There's the Copernicus project. Ensure, it's about, I don't know the acronym exactly. It is a very large project on new grid technologies, which currently is being applied for, but the preliminary selection has been done, and it will be a large project under the lead of KIT. Then Aachen is in there, Siemens and ABB, TenneT and E.ON. So it's a large group, and then I think something like 16 more companies which will also participate in that. So the topic is develop new grid technologies to cope with the challenges of the Energiewende. Okay, so smart home technologies are or in a location which is quite easily looked at. We can run tests there, can do all kinds of things, but the scenario can be transferred to other scenarios, can be scaled to buildings, to factories, and so on. And so when we talk about smart home energy management, we can transport that also into other scenarios where we have larger potential for flexibility than by just looking at a fridge, for example. So a cooling house or an ice house, and some cooling houses in industrial settings have much more potential for providing flexibility than just a small fridge. Okay, that's what I wanted to tell you about smart home technologies. And so we are at the end of this chapter and can come to chapter 5, which is on security. I actually should have rephrased that in smart meter and security, but it is on security and on smart meter security. Do you have any questions? Any remarks you want to make? Nothing? Okay, so let's look at what I have prepared here. Smart meter security. By the way, one remark, you know that next week there will be no lecture. We will have the next lecture in 2 weeks from now, on the 23rd of June. And today we have lecture number 9 and 10. And then on the 23rd of June, we have lectures number 11 and 12. And that's actually more or less what I wanted to tell you. I also said I want to offer you to visit the Energy Smart Home Lab and the House of Living Labs. We could do that on the 23rd of June. We could also do it have just 1 hour of one part, just the first part from 2 to 3:30 as lecture, and then go to the Energy Smart Home Lab and have then a visit to the House of Living Labs at another day, and then have another lecture. So the question is whether I should next time again teach 3 hours the whole afternoon, and then I could offer an extra day where we can visit the House of Living Labs and the Energy Smart Home Lab, or we could do it in a way that I then would also teach on the 14th of July, and we would have just 1 lecture plus visit on the 23rd of June, and 1 lecture and visit on the 14th of July. What would you prefer? Who is for having 1 lecture plus visit and that twice? 1. Who is in favor of having just 2 lectures on the 23rd of June, and then 1 other day where we go to the Energy Smart Home Lab and the House of Living Labs? Majority. Okay, so we do it like that. So then we would visit the Energy Smart Home Lab and the House of Living Labs on the 14th of July. That would be the same Thursday afternoon time, and so we have to organize that. Okay. Good. Smart energy distribution, smart meter security. What is smart meter security about? Smart meters. Let me tell you something about smart metering systems. So what is smart about a smart meter? So this actually here is a photo I have taken in my basement. In my basement there are actually two metering systems. There is the old Ferraris metering system, which you all know, which you know from, because that's the standard metering system, and this is the one from EnBW, which I have there because I was in those projects. And there is a communication device. This is the communication device actually, and this is providing this data that is used in these Stromradar and in the EnBW cockpit. Now, some people transform such a traditional Ferraris metering system into an intelligent device by attaching a small device here, an optical sensor. And you know, if you look at that more closely, you see that there is some circular, like a disc is turning turning around there, and there's always this small red or black area. And so if you have an optical sensor, you just notice after one cycle that we have this red spot there, and this can be recorded, and then this optical sensor is just counting the number of red spots it sees. And in this way, you have a very simple way of measuring the energy consumption in your house, because you just look at how often that red spot moves below your optical sensor. This is a very simple device you can actually put in or install yourself there, and then you have a possibility to have a digital way of measuring the energy consumption without actually taking out that old Ferraris zähler. Okay, one of my PhD students has done that to get some measurements in his house. Very simple device. Okay, now I want to tell you something about something which is more intelligent about the smart meters, and I will also talk only about smart meters for electrical energy. We also have other sensors certainly for gas, for heat, and so on. I will not talk about those. Smart meters are being rolled out in Europe, and like at the end of 2008 in Europe we had something like 39 million smart meter units, mainly in Italy, in Finland, Sweden, Denmark, to some extent in the Netherlands, to some extent in Great Britain, but not in Germany. Only very few. And like 17.4 million smart meters were announced to be shipped in 2011. I did not update this. I don't know how many smart meters we have in the moment. There is some directive by the EU that smart meters will be installed when an existing meter is replaced in new buildings and when an existing building undergoes major renovations. It should be installed. But nationally, this has to be done actually, but in the different nations, the speed at which this is done is different. And so in Germany, we say we don't just put in smart meters, but they have to be safe and secure. And so we have come up with a protection profile, and only smart meters complying with the protection profile actually should be installed. The smart meter I have just shown you does not comply with the protection profile. It's a very simple smart meter. It just measures and sends data. Actually don't know whether it is encrypted or not, but it's not complying with the smart meter with the protection profile. And so the rollout is very slow in Germany. There is one regulation that 80% of the smart meter, I don't know why I always get this line here, 80% of the energy system should have smart meters. And in Germany, this has been transformed into a regulation. And it says that every building or every end consumer consuming more than 6,000 kilowatt hours per year must install a smart meter. The reason for that is that 80% of the energy consumption is from houses, from end consumers, who consume more than 6,000 kilowatt hours per year. And so they say, okay, since it is 80% of the energy consumption, it's complying with that rule. 80% of the energy system should be covered with smart meters. But this is only a fraction of the end consumers, because most consumers in Germany consume much less than 6,000 kilowatt hours per year. And so it's only a small fraction of houses that actually have to have these smart meters. Okay, I should briefly take that away and draw again the 0. So this just shows that in politics somehow you see a certain regulation, a certain policy that has to be implemented, then you find ways to implement that in a way that doesn't hurt you. Yeah? And so those who have 6,000 kilowatt hours consumption per year are not necessarily those that are the most interesting with respect to the energy consumption, where it would be reasonable to actually install a smart meter. So for industrial customers, smart meters are nothing new. So there they have smart meters because they want to have more information about their energy consumption. They have certain standard load profiles, so they want to have some standard loads. They want to have, like there are all kinds of different types of industrial meters. And so the important point is that they need to know at which time of the year they have a certain consumption peak, and from getting information on their energy consumption, they can optimize also their production lines and things like that. So this is something which is not that unusual. The industry is equipped with smart meters. And what they do there is they have, like in 15-minute blocks, they send the active power consumption, the reactive power consumption, Blindleistung, and also the device that is measured and some error code if something, like if the measurement is erroneous or something like that, it's indicated. Or if there's no measurement or things like that. And the requirements on those smart meters are different from in the different voltage levels. So this is the industrial case. I don't want to go that much into the industrial case. I will show you in a moment the other scenarios, what kind of data is sent from smart meters in a household. So what are the advantages if you have smart meters? You have a possibility to actually use time-varying tariffs because you know something about the load profile during the day. So you have more transparency for billing. You get incentives for load shifting without having your load profile of the day. You don't have really an incentive for that. One important advantage is that you have remote meter reading. And this is one of the reasons why in Scandinavia the smart meter rollout has been done some years ago, because there they had a law that they should no longer only have annual meter readings, but monthly meter readings. And in Sweden, the distances to the metering or to the houses are quite large, and so they said that's too expensive. It does pay off if they just install metering systems which allow for remote reading. So this is some feature of a smart meter, and so these smart meters were installed. This is one way the companies could actually save money. Also, remote demand monitoring. You get more information on what's happening in the house. You could influence what's happening in the house, although that means you are not just reading something, you also have to be able to send information to influence what's going on in the house. And it also allows for it allows for better planning of the energy consumption in your region or in a balancing group, because you have more exact information on the actual energy consumption. So this is benefits for the company. Then there is a benefit for the user, real-time visualization. You get transparent view on your energy consumption. Sorry. Then you have sorry. You have a possibility to notice, oh, at this location, the smart meter shows that energy is consumed, but I know that nobody actually has a contract there with the company, and so you can remotely switch off the power supply. And this is one of the major reasons why in Italy smart meter rollout has occurred. This paid off immediately because they suffered quite significantly from people who did not pay their bill, and so now they could easily find out who was consuming energy without paying, and they just switched off the power supply. And this really led to a lot of savings for that company. In Germany, we don't have those large distances between houses. We don't have people who steal the power, and so the incentives are not that large. Nevertheless, there are more benefits that you get from knowing something about the power consumption at the endpoints of the grid. There are many benefits for the distribution system operator, for the utility company, such that it would pay for those companies to actually install smart meters, but they usually say that, well, who has to pay? Usually the end consumer should pay for the smart meter. And one problem in Germany is that if you want to install a smart meter, then the end consumer can actually decide on what kind of smart meter he would like to have, and he can, even if your standard power supplier has installed a metering system in your house, you can just go to some metering system supplier and ask some metering system operator to install a new metering system, and then just the other metering system is taken out and replaced with a new one. And there's no way to prevent that, because we have unbundling, and the metering system operators are independent from the distribution system operators, and so there's nobody who actually has an interest in installing smart metering systems. And nobody wants to pay, because if they paid for that and then somebody else takes it out, you don't get the benefit and they don't like it. Okay. So the reasons in other countries are remote meter reading, prevent power theft, and certainly you can have also dynamic read frequencies. Maybe you have normally 15 minutes readings, and if you are able to increase that in emergency situations, that could also be an advantage. Okay. Yeah, this is here what I already told you. Here we have in Italy We have the world's largest smart meter deployment. We have bidirectional communication, not only measuring what happens. It's not just reading, but also sending control signals, in particular being able to prevent power theft. Communication is using power line control. In the United Kingdom, smart meters should be in all homes by 2020. I have no idea to what degree they actually have implemented that. In Germany, you know that we have a rule that in new buildings, and if you have a complete renovation of your house, you should install a smart meter. But there's no communication module required by this directive. And so it does not mean that you can actually communicate. It's only you can have something there inside your house, but it's not necessarily communicated to the outside. In Sweden, monthly readings requirements led to the rollout of smart meters, and there they can, in particular for holiday cottages, which are at far distant places, they can have remote energy control, which certainly is a benefit for them. So the energy provider there actually has a benefit from installing the smart metering systems. In Germany, it is a little bit more difficult because we are more difficult. Like in Sweden, like we had a visit from people from Sweden and Finland looking at our energy system, and when we talked about smart meters, they said, well, in Germany we are so concerned about the privacy issues because we don't want to send all our data about our smart meter profile to the utility company or the distribution system operator. In Sweden, it's no problem for the people because they know if they send the data, they get services back. They get services like telling them as I said, the relative power consumption compared to others in the same group of people. And so they get all kinds of benefits from sending data out. And so they have no mistrust in that the companies would actually use the data against their interest. And in Germany, usually we are not really trusting the institutions that if we send them all our data, this will be something which is beneficial for us. And there is a simple other example that in Denmark, all the everything that you buy, like for every bill that you get, if you buy something, or the receipts of if you buy something, this is all sent to the government, and at the end of the year, the Danish government is sending a list of everything that you have purchased with recommendations how you can use that in your tax statement. In Germany, it would be probably used, like if the government would have all the information about everything that you have bought, they would use that information to check whether you have actually declared everything in an appropriate way. But I assume they would not actually provide you with helpful information on how to use that in the best possible way in your tax declaration. And this is just a different attitude, a different culture. And so if you want to install a technology, you have to be aware of different technological cultures. So in Scandinavia, they have no problems with providing all the data. In Germany, it's no-go. In Netherlands, it's also no-go. They had installed some metering systems, and there were privacy concerns. They had to take them out again. And so this is a difficult topic because it's not just a technological problem, but a social technological problem. And so you have to consider how people actually deal with technology and what kind of feeling they get. And so that means when we design technology, new technology, we also have to be aware of that and try to design it such that we can actually successfully install reasonable technology. Okay. Now, what kind of data do we actually need to communicate? So what kind of data, like in here, for example, taken as an example, the ENBW metering system. What is the relevant data that is sent? Now, different metering systems send differing types of data. But one of the standards is that the typical accounting period is 15 minutes. You know that the typical time resolution on the markets, the spot market, is 15 minutes. This will go down to 5 minutes. This is just now taking place, like it's people talk about that, so it will go down to 5 minute intervals. Probably the reading intervals on smart metering systems will also go down in the standard down to 5 minutes, because then you have the information, exactly the information that is relevant to the periods, the time resolution on the markets. Okay, currently it has been 15 minutes, and now the question is, what are you actually measuring there? So what is measured is, like, there's a counter of how much energy you have consumed. And now you have this 15 minutes interval, and you look at how much have you consumed here at T0 and T1, where T1 is 50 minutes later. So you are having your count of energy consumption at the period's beginning, the count of energy consumption at the period's end, and then you have the average power during that period. Yeah, you just take the difference, you know how much you have consumed on the average. ENBW, smart metering system, actually does a little bit more. So I just copied 2 lines from the data that I can go to the cockpit of ENBW and download all the data that they get from me. At least that's what they say what they get from me. I don't know whether it is exactly the data, but this is what they actually sent me. So it is the date, the time, you see here at midnight and 15 minutes later. And here they not only give the average power consumption, but they get, like, this is the average power consumption. Then we have the maximum power consumption that period and the minimum power consumption that period. So this is interesting, that they not only provide this measurement at the beginning and the end, but they also, since they have real-time or 1 hertz reading, they can just look at what was the maximum value in that period, what was the minimum value, and they also provide those measurements. Now this is important. If you, let's assume you have something like your power consumption looks like this. Such a peak, you remember from the Stromradar, which I showed you, this picture, there was a peak. You don't see these peaks if you just report the average power consumption. But you know, or you get to know about those peaks if you also get the maximum value and the minimum value. So this has additional effects, in particular if you want to find out what has been going on in that house. If you only get average data, it's more difficult to find out profiles of devices than if you have also the maximum and minimum power consumption. And then they also provide the current counter. Now this does not change here between these 2 time periods, because this is the high tariff, so the day tariff, and this is the low tariff. I don't have different tariffs, but nevertheless they have 2 counters for that. And so only the counter for the low tariff has been changing in that time period. So this is what I said here, count of energy consumption at the period's beginning, and this is the count of energy consumption at the period's end. So if I always report the count of energy consumption at the period's end, then that's sufficient to have that. So this is what one could do, just provide that current count of energy consumption. And then from that series you find out what the consumption has been, but only the average consumption. So this is the data that energy, or that EnBW has about my energy consumption in my house. So it's not just one piece of information. It is the day, the time, 3 readings, or 3 energy consumptions, and 2 counters. This is quite a bit of information which is sent. Okay, but this this will be different from smart metering system to smart metering system. This is what EnBW is sending. I guess that Discovergy, as I said, they provide data on a 1 Hertz basis. Like, that means every second they will send different information. So you could also, which they do not send, like something like reactive power. So the power factor would also be of interest. What is the local power factor? The deviation of voltage and current power. And you could look at the voltage. The voltage is not measured here. If they say, like EnBW actually told me that if they would actually make the dynamics of the voltage transparent to the user, they would get many phone calls, because the voltage is changing quite significantly and quite dynamically, and it does not really, it's not an information that you really need. So it is of interest, certainly, if you have high deviations of the voltage, then your devices might suffer from that, but this usually is not measured and sent to the companies. Okay, it's 3:30. I would like to make a break now, and we start again in 15 minutes. Thank you.